Okay, in this question we've got two parallel plates being tested before being put in use in an electron gun. The plates are connected to a 160 volt source, so that electric field exists between the two plates. The distance between the plates is 0.35 centimeters, and each one has an area of that. Okay, 1 times 10 to the negative 4. So this is basically a big air-filled capacitor with 160 volts applied. Calculate the charge stored on the plates. Hint, calculating C may be useful here. Okay, so we know that Q is equal to CV. We already know V, and we're given a hint that calculating C is going to be useful. Clearly it's going to be useful here. So C, we know for an air-filled capacitor, is epsilon naught A over D. If it's not air-filled, if it's filled with a dielectric, then we have to also include the little epsilon R here. But if it's an air-filled one, that's all we need. And in this case, we have we need to use the permittivity of free space. Which is 8.85 times 10 to the negative 12. And then multiply that by the area, which is 1 times 10 to the negative 4. And then divide by the distance between the plates, which, let me just remind myself, was 0.35 centimeters. So 0.35 centimeters is 0.35 times 10 to the negative 2. Okay, and that should give us the capacitance, which is 8.85 times 10 to the power of negative 12 times 1 times 10 to the power of negative 4 divided by 0.35 times 10 to the power of negative 2, which gives us 2.blah times 10 to the negative 13. 2.5, was it 53? 2.53 times 10 to the negative 14 farads. Is that right? No, 13. Okay, let's fix that. Okay, we now know the capacitance, so now we can work out what charge is stored. Q is equal to C times V, which is equal to 2.53 times 10 to the negative 13 times 160, which is equal to, so just rather than taking that rounded number, I'm just going to take the number from my calculator and multiply that by 160. And I get 4.05. Times 10 to the negative 11. Right? Yep. Okay. So that gives us the charge, and we should also really put the correct units. Units for charge are coulombs. Alright. And in fact, we should have it to the correct number of significant figures. The distance was only given to 2, so that it was 4.04 blah 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 something. So in fact, it should be 4.0 times 10 to the negative 11. All considered. It looks like it should round to 4.1, but that one was already rounded from 4.048 something, or 4.045. Alright. The voltage is now doubled. Calculate the energy stored in the electric field. Well, the energy is equal to, whoops, it's not letting me write. the energy is equal to half QV. But if we double the voltage, you'd think the energy would double. But if we double the voltage, the charge also doubles. And so it's going to be equal to a half times 2Q times 2V, which is equal to a half times, what was the charge? 4.05 times 10 to the negative 11 times 2. And then it's going to be 320 for the voltage. So it's going to be that. So a half times 2Q is just Q times 2V times 2 times 160 is equal to 1.29. Let me just, oops, eraser. Let's put in the answer here. What was it? It was 1.3. 1.3 times 10 to the negative 8. Joules. Okay, nearly done. I'll pause there and I'll make another video for the last page.